Welcome to your online source for calculator tutorials. In this tutorial, we will learn how to enter a regression equation for data that we've already compiled. If you recall our previous tutorials, we looked at entering univariate data, bivariate data, and then producing a scatter plot from that data. The third step in that series is to do what we're going to do in this tutorial, and that is to calculate the regression equation for a set of data. If you are unfamiliar with the data set being used, go back and look at the previous tutorials. Let me remind you that in the last tutorial we did come up with this scatter plot that we're looking at now. And the idea is we would like to be able to say, well, here's how this data trends. In other words, here's what we expect generally for if we were to redo this over and over again. Here's kind of how we would expect the things to fall. So we want to come up with a line which best fits the data in some sense. As you can see, we would want whatever line going through the data to fit it would go through the most points possible. So we're going to get something along maybe this direction. It's going to be pulled up a little bit because of these 2 points over here. In order to create a regression equation from data, let me remind you that we have in our lists data in both L1 and L2. This is the ranking data, this is the frequency data. Let me quit out of that right quick. In order to create the regression equation, you have to go to the Stat menu and then locate the Calc tab. So arrow over to the Calc tab. And what you'll see at number 4 is a linear regression, and in fact it tells you that it's looking for a function of the form ax plus b. Right below it is quad reg, which stands for quadratic regression. It's going to try to fit a parabola to the data. 5 is cubic reg, or 6 is cubic reg. It's going to try to fit a third order polynomial. And as you scroll through this, you'll see that there are various types of regression equations we could fit to the data. A lot of it is just trying to figure out, exactly what type of curve is probably going to best fit the data that we have. Now, in most cases, in this class, we're going to be using linear regression. So that's the example that I'm going to show to you here. Linear regression is option number 4. So the shortcut to being able to produce a regression equation is to hit Stat, arrow over to Calc, and hit 4. So go ahead and hit 4. And this will bring up on our home screen the command linreg ax plus b, linear regression. This uses a couple of different options or arguments to create the actual equation. First thing you have to do is tell it where your x variables are coming from. In our case, that's L1. So the x variables are L1. Let's hit comma to enter the second variable. It'll tell us where our y variables are coming from, and that's the L2 menu, or L2 list. So this is going to be typical of most of these calculations. You're going to put in the x list, comma, followed by the y list. And then the third optional argument that's actually very nice is once it's done calculating the equation, we would like for it to put the equation into our y1 so it'll graph the line along with our scatter plot. The way to do that is by going into the vars button over here on the right hand side of the keypad, selecting the yvars tab by arrowing over, selecting function, and then it gives you all of the different y1, y2, y equal editor variables. Let's go ahead and select y1. So get used to seeing this on your screen. There's going to be several opportunities this semester to use regression equations, and almost all of them are going to look exactly like this. You're going to enter linear regression L1, L2, Y1. Hit enter when you're done. There'll be a couple of things pop up on your screen. The first thing you'll see is the form of the equation it's trying to create. A represents the slope for this equation, so that's approximately 2.4. B is the y-intercept, so that's 5.5 approximately. But notice when we go into our y equals now, that equation is entered into our y equals. Note also that plot 1 is darkened, meaning our scatter plot is still turned on. So when I hit the graph button here in a second, not only will I see the scatter plot, but I'll see this new regression equation line. And there it is. This is the line which best fits the data. And remember, what we mean by that is, in some sense, the distance from this line to all the other data points is minimized. In other words, if you draw another line in there and I calculate the distance between your line and all the data points, it'll be a larger distance on average than this line that we just drew. So in some way, this is the line which best fits the data. Alright, this concludes the creating a regression equation tutorial. Feel free to replay this tutorial or browse any of the other available topics on the course webpage.